Creo Parametric's model-based design approach and associative capabilities set it apart from other CAD systems and make it a foundational component of the digital thread, driving activities throughout the product development lifecycle. In this demonstration, we'll see how Creo and Windchill develop and maintain this powerful digital thread in product development and manufacturing. With a direct connection to the Windchill server, we'll open the product structure for this snowmobile and check out the ski assembly. Creo lets designers easily dive into complex assemblies to isolate specific parts. Here, we're continuing our work on the snowmobile ski. Creo lets us easily build structural features, create surfaces, design molds, and simulate and analyze our designs, all without ever leaving Creo, even for parts with complex Class A surfaces. In this case, we're using Creo's flexible modeling tools to finalize a key structural rib at the front of the ski. Next, we'll mirror the part. And finally, we'll use a Boolean operation to modify the bolt hole cutouts in the center of the part. To ensure we meet our design requirement of supporting a load of 750 newtons, we'll use Creo Simulation Live, which equips us with structural analysis feedback based on loads and constraints in real time as we design. Our analysis reveals that the maximum stress on the ski exceeds the factor of safety as defined by the design requirements. Taking a closer look, we can see it's concentrated near the middle of the ski. Checking deformation, we can see that it also exceeds the maximum displacement defined in our requirements, and we can watch the animation for more detail. To reduce the stress and deformation, we'll redesign the rib at the front of the ski. Specifically, we'll add another rib to increase its stiffness. Right after we make the change, CSL updates in real time, showing us the new deformation, now within our displacement and safety requirements. Similarly, checking the maximum stress, we can also see it now falls within the factor of safety. This instant feedback gives us confidence in our design decisions, so we don't need to send the part to another team to check its integrity. We can quickly validate the design ourselves and iterate until we satisfy the requirements. With a strong, lightweight design, we'll use Creo's mold fill simulation tools to gain powerful insights as to whether its mold will fill without production problems. Creo Mold Fill Simulation equips us with a granular perspective on moldability, volume shrinkage, melt front time, and more. Before we send the part out for manufacturing, we'll use Creo's model-based definition tools to ensure the part is fully defined. With MBD, we add product manufacturing information to the 3D model, including part dimensions, geometric tolerances, critical features, and more. These annotations enable the digital thread within our organization by establishing the model as the single source of truth that drives all downstream activities in engineering, manufacturing, and service. I'm designating this dimension as a control characteristic. Control characteristics, like model items, capture and communicate design intent and critical product information required by manufacturing. We'll also use GD&T Advisor, another key feature of model-based definition. GD&T Advisor ensures that GD&T is applied correctly according to industry standards and that the entire model is correctly constrained. These annotations support downstream processes, including tolerance analysis, inspection, and other production activities. Finally, we'll create a general profile tolerance rule, which defines the acceptable tolerance along the edge of the ski so that it properly houses the carbide, a component that cuts through the snow and gives the snowmobile stability. This profile tolerance rule automatically captures all non-constrained surfaces in one annotation semantically. Now that we've designed, validated, and annotated the ski, we'll check the part into Windchill. Checked into Windchill, this engineering data gives our manufacturing team essential data to manufacture the ski assembly. Here, we can see the ski's control characteristics, which help us make manufacturing decisions without having to open Creo models or other CAD systems to verify them. After we check in models with annotations designated as control characteristics to Windchill, Windchill's BOM transformer can access the designated annotations. Transforming the engineering BOM to the manufacturing BOM enables our various teams to leverage 3D models and product specifications throughout all aspects of the business concurrently, much sooner than they would in a traditional sequential product development process. This gives teams access to a continuous, reliable flow of product data, breaks down silos, increases collaboration, improves product data quality with less manual input, reduces scrap, and decreases time to release. After deciding to produce the mold in-house, we'll use Creo's mold design tools, which enable us to create, modify, and analyze plastic features, all within the context of the part. The native Creo model of the ski is dynamically linked to the mold tool design, which means that any changes we make to the model will automatically update the mold. For example, the profile tolerance from the ski is transferred to the mold. To further assist in the mold design process, we'll use Creo's Expert Mold Base extension, which standardizes and automates the design of injection molding tools, integrating standard part libraries and intelligent templates, enhancing efficiency and flexibility in mold design and significantly reducing time-consuming tasks. To produce the mold, Creo's machining tools allow for fast, high-precision machining, supporting operations like milling, turning, and material removal simulation. Referencing the geometry of the design model sets up an associative link between the design model and the workpiece. Because of this link, when the design model is changed, all associated manufacturing operations are updated to reflect the change. Our team can also leverage the MBD data for quality assurance, specifically during the coordinate measuring process, which ensures that our design meets the specified tolerances and quality standards. With a completed mold tool design, we'll check it into Windchill. Like the ski itself, the mold tool is now available for all downstream manufacturing activities. With the mold tools checked in, the updated product data is used to create the process plans, what needs to be done on the shop floor to produce, inspect, repair, or maintain the part. If we need to design variants, this single source of truth simplifies the process of authoring every variation of manufacturing and service information. We can also use these process plans to generate work instructions. With a thorough process plan, the ski is now ready for manufacturing. After a full season out on the trails, we've learned a lot about our riders. Our most important insight is that they took the snowmobiles to new extremes. Our manufacturing team has already created a change task for our design team to modify the ski so that it can stand 1,000 newtons of force rather than the 750 newtons specified in the original design. This change task already includes all automatically collected documents associated with the affected part, which the designer can open directly from Windchill. After receiving the updated load requirement, the design engineer will change the force relation to correspond with the change task. Updating this parametric relationship causes Creo to update the simulation, which reveals the design fails with respect to stress and deformation. To redesign the part, we'll check it out from Windchill. To strengthen it, we'll increase its overall length and width. Once we've done so, the design will regenerate to show the updated annotations. After doing the same for the ski's thickness, we'll make an important change to the front of the ski and increase the length of the rib in this area. These design changes affect the part's surfaces, which in turn affects the tooling. But because Creo is associative, even high-fidelity surfaces will propagate downstream and automatically regenerate steps and processes throughout engineering and manufacturing, from GD&T all the way to the tool path for the updated mold. Reviewing the analysis, we can see that the stress and displacement meet our updated design requirement and fall under the factor of safety. We'll rerun Creo mold analysis to confirm that the updated ski can be produced, again with the insights like moldability and melt front time. Associativity ensures that we don't have to redo the upfront work to set up the mold for analysis again. Because the design is associative, the annotations have also regenerated, including the ski's overall dimensions, thickness, and force requirement. The profile tolerance note we created earlier in the demonstration automatically collects any uncollected surfaces into it and applies the profile tolerance applied to it, successfully preparing the design for manufacturing. If we updated GD&T, we only have to do so for features critical to function, safety, or quality. Everything will use the profile tolerancing rule to update automatically. Looking at the mold assembly, when we click Regenerate, we can see it also updates based on the new ski design. Spanning the entire design process, the digital thread connects the core design to the tool design. This means that the tools and tool paths will update dynamically based on the new design of the model. Even the material removal simulation will account for any new or modified features. Now that we've finished the new ski and prepared it for manufacturing, we'll check it back into Windchill with the embedded browser. This check-in gives you the ability to push these changes downstream to manufacturing objects through the change process, like the work instructions we see here. With the new ski, the new snowmobile variant is ready for the next season and fit for a new market. In this demonstration, we've seen how Creo's powerful modeling, simulation, and model-based definition capabilities allow us to efficiently create and modify complex parts. We've also seen how, with a direct connection to Windchill, this product data can be made available throughout the product development process, empowering teams to work concurrently with trustworthy information tied to a single source of truth. This is the digital thread powered by Creo.